Okay, it's 2 p.m. and we would like to start our today's IOER-Forum session. My name is Tobias Krüger. I'm here at the Institute together with my colleague Professor Martin Wenisch, who is giving a short input after the main talk of today. I want to welcome Mr. Dani Arribal-Bel. He is a professor at the Department of Geography and Planning of the University of Liverpool in UK, and also the Deputy Program Director for Urban Analytics at the Turing Institut. And in Liverpool, he's a member of the Geographic Data Science Lab. So, and since 2019, he's also a co-editor of Environment and Planning B, Urban Analytics and City Science, and is also since 2020 also in the editorial panel of Journal of Royal Statistical Society Series A. And Daniel's main research interests are urban analytics, geographic data science and new forms of data, and open source scientific computing and reproducibility. And yeah, he's busy in developing tools and libraries for statistical analysis. And today he is going to talk about the topic of understanding urban form and function using urban analytics. And we would like to start with your talk, Dani, and afterwards we will have an input from Martin, who you can see on my side. And Dani is already sharing his screen, so we are looking forward to your talk, please.
Okay. Can I confirm everyone can hear me? Excuse me. Hear me fine and see my slides correctly? Yeah, all good? Okay, excellent. So thank you very much for the kind introduction, and thanks everyone at the IOR for the invite and for the patience in working with me through all my family issues that happened the last couple of days. In the end, it's great to be able to be here today. So as has been said, my name is Dani Arribal-Bel. I'm based. I wear two hats these days. I have one hat at the University of Liverpool, where I'm professor in geographic data science, and then I have another hat at the Turing Institute in London, which is the National Center for Data Science and AI, where I'm deputy director for the program that's in charge of landing data science and AI on cities and regions. What I'm going to present today actually is a little bit of both hats. It's a research project that I developed in Liverpool, but it was a fellowship that I want to spend some time at Turing, and that was eventually it was my first foot into Turing, and then later on I got more involved with the program at the leadership level. But this was sort of the beginning of my relationship with Turing. It's a project that we call the Urban Grammar, and I'll say more a little bit about what it is about in a second. But just to note that all of the stuff that I'll be presenting today is joint work with Martin Fleischmann, who used to work at the project and is now at Charles University at the University of Prague. So it is possible that if you have very sophisticated and complicated questions, I will defer that to Martin by email, because he was the bright mind in the project and I was sort of overseeing everything else. But a lot of the real nitty-gritty work was Martin behind the scenes. Okay, let me see if I can get the slides. Yes. So I kind of more prosaically reshaped the title. Oh, and final one logistics, about 45 minutes, correct? For the talk? Yeah, so I'll aim to be done at quarter till. So I was saying I reshaped the topic a little bit into decoding urban form and function in Great Britain, and you'll see in a little bit what the decoding and what we mean by form and function. And the Great Britain is where most of the application that you'll see. The conceptual part is more general, but the application is on Great Britain. So let me start a little bit by saying a couple of words and adding a couple of slides on what we consider, what what we used for this project form and function, urban form and function, because it's pretty fundamental to everything that comes after in the project. So first of it, what it is. When we talk about form, we are implicitly asking the question, what does a place look like? What's the physical structure and what's the appearance of cities? And when we talk about function, what we have in mind, and when I say we, at least Martin and I, for the context of this project, these are really big words, so other groups might interpret them in slightly different ways. But when we talk about function, what we have in mind is what is a place used for? What are the activities that take place within that environment? Why we think it's important to spend 3 years of our lives on a big project looking at form and function in urban environments or in cities? It really boils down to these two statements. We think form and function are important for urbanists because at the same time, and this is a rare property, at the same time they encode the past, but they also frame the future. What do we mean by they encode the past? Everything that goes into the making of cities, anything from geography, topography, the history of a place and of a population, of a people, the technology that's available in a given time, the social values that are prevalent in that moment in time, all of these aspects get encoded into the urban fabric. Everything that is built into cities, from buildings to the more general layout of neighborhoods and the entire city, it's an encoding really of all of these aspects of geography, history, technology, culture, societal values, and so on. So they're a great book if you want to study the people who made cities. They're a great book reflecting them. So if we're able to decode in some way all of that is going into the making of a city, we're really decoding not only the making of the city, but the making of the society that made it. But at the same time, I mean, these on its own would probably warrant some time and effort. But at the same time, the other interesting aspect of cities, of form and function in cities, is that once they're in place, they not only encode everything that made them, but they also frame the future. They also made certain things possible and other things impossible. And a lot of things are more encouraged or less encouraged. Anything from productivity to sustainability to quality of life is directly affected by the shape, by the form, and by the function of cities, by how function is spatially arranged on cities. So if you want to understand how to make cities or how cities could become more sustainable, for example, you really need to pay attention to form and function. If you want to study how to foster productivity in urban spaces, there's a clear link to the spatial structure and how we experience cities. Ultimately, the quality of life that we're able to have in cities is also directly linked with what the containers, what those cities are, and what the content of the cities are. The function is structure around space. Now, this is not something that Martin and I came up with when we started on the project a couple of years ago. This is something that has a really long literature in quite a range of areas. And here I have a couple of examples from the urban and regional economics literature, because a lot of the project was born in that domain initially. But there's a lot, almost any social science literature will have a domain or a subdomain that is focused with cities. And I think in all of them, the context where urban phenomena happen is important. And this is not only the case in the academic literature, which it is, as I just said, but also in the policy arena. And this is something that has started becoming actually more relevant, I would say, in the last 10 years, probably on the back of the climate change crisis making its way and the need of rethinking what our home looks like, our home on Earth looks like. But whichever the reason, organizations anywhere from the World Bank to the OECD to the UN, which in 2016 launched the New Urban Agenda, which is about a lot more than just form and function, but the aspect of spatial structure of cities is also embedded in that document, and that permeates pretty much everything the UN does that touches cities and human settlements. And perhaps more recently, the whole discussion around 15-minute cities implicitly the proponents of 15-minute cities probably found a sexier way of presenting the ideas, but at the core of it, a lot of what that discussion is really about how we structure function, what are the functions that we want our cities to provide, and how we structure them spatially in a way that they're accessible and available to as many people in the population as possible. So this idea of looking and considering form and function is really important. We think it's really important, but also it's not only us who think that, is academics and policymakers who are picking up to these notions as well. Now, how do we measure form and function? And for a quantitative mind like mine, it's not always the case, but it helps that if you want to if you care about something, it's important that we think of ways to measure them and to quantify them, or at least characterize them appropriately. And traditionally, there's different ways. This is an opinionated view on how the field or different fields have looked at form and function. But on the one hand, there's a really long tradition and big industry on land cover and land use classifications. And this is not only about cities. In fact, that's our main critique of this approach, is that traditionally, because they're land cover and land use, and most of the land is actually not cities, it's about 3 to 5% on average in the world. These classifications don't pay a lot of attention to the urban fabric. They basically have a class that defines cities, and that's almost like the boundary where the classification granularity ends. And on the other hand, these land use classifications, they're not necessarily from the social sciences. A lot of them are actually more environmental sciences and physical sciences. They're focused on understanding the cover of the surface of Earth. That they're hugely used in climate science, in spatial planning, and engineering, and a little bit, and increasingly more, but a little bit in social sciences too, in urban domains. On the other hand, coming initially actually from geography, and perhaps I'm biased here because it is an invention of Liverpool. It was the first proponents were based at Liverpool 50 years ago now. But there's a long tradition also in starting in sociology and geography, but also then moving into industry and marketing of what's called geodemographics, which is about classifying places, not by what places look like, but by what the population who lives in there look like. And I put this in this slide because there is a lot of lineage and a lot of that tradition that we're going to borrow and we're going to get inspiration from for what I'm going to present later today. This is really about studying places by their populations, and it's about taking a multidimensional approach to understanding populations, and then using that to define what places are really. And then in the middle, there's a little bit, although not a lot, that kind of tries to strike a middle balance. And these would be classifications of urban land use classifications, and these are less, I think, less developed. They're traditionally trickier to do, I think, and they haven't received as much attention. You don't have a global urban land use classification, for example, the same way that you have several worldwide land cover classifications and in some ways land use classifications. These are land use classifications which are defined explicitly to measure or to consider cities. So there are land use classifications for looking at 5% of the land, and they provide a lot more granularity than traditional land uses. They just aren't as commonplace. So what you have in the image there is the Copernicus Urban Atlas, which is probably the best example, the best illustration, where I think is European Space Agency, if I remember correctly, has created this classification over several points in time and for several cities. But again, you have to start from a definition of city, which I'll argue later is not problematic, but is limiting. And then you have to be a lot more specific. What I will say about this classification, then I'll leave it for later to elaborate a bit more, is that in some ways, these classifications inherit a lot of the philosophy of land use, traditional land use classifications, and then take it into the urban domain. And what I mean by that is that they take this atomic approach, atomic in the sense of defining individual uses, things like industrial, residential, transport, green space, and those form the basis of that classification, right? And they are a lot more granular than the global ones, which are effectively have one or two classes, urban or dense urban. But they're still taking this atomic approach, and it's something that comes, I think, from the land use tradition, where you're creating classification at the pixel level, and you're trying to identify what that pixel is individually. What is the use that it takes? And we're going to depart from that approach. I'll say a little bit more later. But we're going to depart from that approach in some fundamental ways. And this is not a critique. It's just to say one of the things that we do differently and we think is complementary is going to be on this aspect. And then when we started thinking on this project, we're trying to make the pitch of what we're going to do, and one of the areas that struck us as an advantage of the approach that we will be taking is that we're providing a detailed, scalable, and consistent classification of form and function. And when we started looking into the literature, we kind of half joked, but not fully, that of these three attributes, you can pick any two and you will find a huge literature on them. You can pick a detailed and consistent classification, but it won't be scalable. You can pick a consistent and scalable classification, but then you're losing detail. And you can maybe pick a detailed and scalable, but then it won't be consistent. And depending on what your goal is, and we argue that if you want to take form and function seriously, you really need the three of them. You need to be detailed because a lot of the fundamental processes that we care about when we look at form and function operate at pretty small scales. You need to be consistent because if you want to compare places, you need to be comparing apples to apples. And ultimately, you want to be scalable because you do want to compare places. You want to compare the microprocesses that are going on in one city with those that are going on in another, with a level field that allows you to give to make meaningful comparisons. So this is what we're trying to pitch and to do in this project. One point: how does these seminars usually take questions? Do I take them as they go, or I go through my presentation and then I address them in the question section?
This is, I think it's up to you what you would like to handle it. It's good for us. So if you want to have it directly answered, so please feel free. And
I might carry on because some of the questions probably will become answered. Hopefully, if I do my job correctly, they might become answered later.
Okay, perfect.
But if not, I'm very happy to pick them up later in the questions time, and it'll also help me to stick to my timeline and not believe that I've taken too much time for answering questions.
So we keep it for later, right?
So yeah, I'll take questions later. But if people are happy to drop them in the chat, don't wait for them and feel free to put them on the chat. Happy to collect them there as we go. Okay, so then enter the Urban Grammar Project, which is a fellowship that I had to spend some time at the Turing Institute. I don't know how things work in Germany. The way they work, at least in the UK, these days you need to take certain hype bands or certain hype words on the title if you want to get funding. So I tried my best, and I think at least one out of every two words is probably hype on this one. The idea was learning an urban grammar from satellite data through AI. I'm going to talk mostly about the first part, the urban grammar aspect. And in fact, one part of the urban grammar, the idea of the urban grammar was, if you think of how language works, it's a grammar is the set of rules that explain or that govern how the building blocks of language or the building blocks of knowledge, which are words, combine to create meaning, right? So the translation that we're trying to do with this project was, can we take the can we try to infer what are the rules by which the building blocks of cities combine over space and over time to understand how cities get built, how the meaning of urban kind of gets constructed. And what I'm going to spend most of today actually is on the building blocks part, which is what we call the spatial signatures, the equivalent of words, these building blocks. And I'll say more in a couple of slides. What we're trying to do with this project is ultimately building characterizations of space that are based on form and function and are designed to understand urban environments. And this is one sentence, but it basically underpins 3 years of our work. So let me unpack it a little bit more to give you a bit more context. The project ultimately is about building characterizations of space. It's about building typologies and creating new ways of delineating space that are useful for understanding cities. So if you were coming here to, I put this almost as a forewarning in case there were any economists in the room, because they're always really focused on understanding how A causes B or how B relates to C from a causal perspective. That's not what we're trying to do in this project. We're trying to build a new way of characterizing and describing the landscape that is focused on these aspects. It has the focus on form and function, and this I think is a big departure from other classifications that try to delineate the landscape. We're not entirely focused on land use. We pay very, very little attention to land cover, and we even pay not a lot of attention to populations, like geodemographics, for example, might do. We try to build classifications that describe places by what they look like, their form, but by the activities that take place in them. And those activities might happen or might be carried out by people who live there or by people who don't, people who are passing or people who are working. And then ultimately, and this is also, it seems like stating the obvious, but it's not, it's a classification focused on urban environments. And it's important because the classification will actually not be only for cities. It's a classification we're going to apply to the entire landscape. So every square centimeter of Great Britain is going to have a label in our classification. That doesn't mean that every square centimeter of Great Britain is urban. What it means is that everything that we design in this classification is to better understand urban spaces, which is to say, we're going to give a pretty vague definition to 90% of the land, and we're going to try to add more detail to the remaining 10%. Okay, so the first flagship product of the project was this idea, this notion of the British signatures, which was an implementation of this idea of building classifications of form and function, which we call spatial signature classifications, for the case of Great Britain. It's something we worked on a couple of years ago, so it has the benefit of being mostly published at this point. So if you're interested, there's a lot that you can play with, and if you're getting bored by my voice, you can go on that URL on the slide, urbangramarai.xyz/story, and there's an interactive map of the data product we built, and there's a sort of an interactive story on how we build them and what it is. It's ultimately a classification with 16 classes, with 16 types, that, and I'll say more in a second, but that almost hierarchically stack among each other from the least urban to the most urban. The least urban, you can think of the Scottish Highlands in the north of Great Britain. The most urban, as it happens, is Soho in London, and I'll say more in a second. We wrote a couple of papers, one more on the conceptual approach of building form and function classifications, and then we did one that is very, very technical. So if you're interested in all the nitty-gritty technical stuff on how we build this particular classification, we have a data descriptor in scientific data that explains everything in detail. What I'm going to give you here is just the overview, the non-technical description on how we build this classification. And it unfolds in 3 acts, so to speak. One is building the spatial unit, which we define our own and roll our own spatial unit, and we call it the enclosed tessellation. Then how we embed into that spatial unit form and function, and how from that we build the signatures delineation. So the first part is building the spatial unit. Why did we spend so much time seemingly on defining a spatial unit when there are so many available? And the short answer is that we think no one cut it good enough to, or no one was good enough to do what we wanted to do. So we had to roll our own. Let me tell you a little bit about how we build it, and then I'll tell you a bit more about why we think this is a good approach. The enclosed tessellation is really a combination of two main groups of elements or features that we use to delineate space. Ultimately, what we're trying to do here is create what I loosely refer as a very large cookie cutter that you can put on top of Great Britain, and will delineate it into very tiny units. Some of them are not that tiny, but in most cases they're fairly tiny. So the way, and what we really want to do here, which is why we didn't go with something else, is we want this spatial unit to be matching the underlying process of what we want to look at. We want a unit that is ideally designed for measuring urban form and function. And what we found is that most of the units available that we were aware of are not great matches. You can think of uniform grids, or you can think of administrative boundaries like postcodes or census geographies. These are units that are not designed for measuring urban form and function. In fact, in the case of postcodes, they're defined in a very operational way. They are areas that a person can walk within a day to deliver the mail. So that, may or may not match the form and function, but is not designed for that. And then there's also really rich literature on architecture and urban morphology that tries to also define units that are specifically built for understanding morphology or for understanding urban function. The problem with what we found was that it was really hard to scale. It was really hard to scale in a way that covers the landscape in an exhaustive way. The holy grail of architects is and probably everyone in the room knows it, is the plot, which is almost like this mythical notion that the more you read about it, it seems like the less you understand what exactly it is and how to operationalize that at scale. But what we're trying to go is loosely speaking, if that helps you understand, we're trying to go for an operational measure of the plot. And of course, if we have to give some concessions, because there's no such thing as free lunch. So we start with what we call delimiters, which are elements of the built environment and the natural environment, actually, that can act as delineation boundaries for these polygons that we're after. And in particular, what we'll be using is the street network, coastlines, rivers, and railways. I think those are the main ones. We blend them all together into one layer, and that gives us the start of our initial units. So already at this stage, you can already imagine that the polygons that will result from this approach in the center of cities will be much more granular, effectively will be blocks, than the ones that you would find in the middle of the countryside, where you would find really large plots and swaths of land that don't have any river or any coastline or any road effectively delimiting it. And that's on purpose. That's exactly what we want. We want a spatial unit that is granular and fine-grained where we care about in cities, and that is pretty loose and vague where we don't care about in the middle of the countryside. Now, blocks, however, can be pretty different in some cases. You can think of great examples in the world. You can think of blocks in Manhattan where one phase it's full of industry, banks, big buildings, and the back of that is fully residential. So that's different type of character. We want to capture that. So the way that we have of subdividing blocks or subdividing areas with areas in cities is by bringing in building footprints, or by bringing in buildings. So we combine this resultant geography that we have with building footprints, and then the resulting area is what we call this enclosed tessellation. The name tessellation comes from a paper that Martin published for his PhD, where he defined a spatial unit of analysis for deriving morphometrics and for look at urban morphology entirely from urban footprints. So effectively, it draws a tessellation that fully exhausts and fully covers space from buildings by attaching every point to the nearest building where it is, and then using that rule to delineate space. We do that in an enclosed way, in the sense that we take that algorithm and apply it within each of the blocks that we've generated before. Because we think that it's important that the space is first delimited by the delimiters, by things like the street network, rivers, coastlines, and so on. And then if there's more than one building in one of these enclosures, we subdivide them with this tessellation algorithm. And that gives us as I said, a gigantic cookie cutter that gives us 14 million polygons for all of Great Britain. For each of those polygons, we then derive a set of characters that describe form and function. For form, we use about 150 different descriptors from the field of morphometrics. And then from function, we take a lot of information on the context, traditional land use classifications, workplace classifications, POIs, points of interest on amenities, hospitals, schools, museums, supermarkets, etc. And then arrange it for each of these polygons and feed all of these into a clustering algorithm, an unsupervised learning algorithm that groups polygons that are similar to each other in the same class and polygons that are dissimilar in different classes. And that's what gives the spatial signatures. Every of these tiny polygons will have a label, a class, and then because a lot of them will have the same class and will be contiguous, then we dissolve those boundaries where they are in the same class. And that gives rise to the classification that we're using. I'm going to speed up a little bit just to make sure that we can get to the other part. But if there are more questions, I'm happy to take them in the questions time. This is just to say that we use a lot of descriptors for form and a lot from function. And if you're interested in which ones in particular, the QR code there will take you to the full table that's part of the data descriptor I mentioned before. We also use context. So some of these polygons are so small that if we want to characterize what they are about, we need to borrow information also from the neighboring context. So we use some of those descriptors that I mentioned in the previous slide are not only about the polygon itself, but also about the surrounding polygons. And we weight that by distance so that the characteristics of polygons that are slightly further away get a slightly less weight on the computations. And ultimately, this is, as I said, it's a data set. So it's a data product that we released openly that you can explore on an interactive map, and that if you're interested, to go further, you can download as a data set to open on QGIS or on your GIS of choice. And it's available. It's open license, so you can do whatever you want with it and build on top of it. Okay, in the last 10 minutes that I have, which I hope it would be a bit more, but my Spanish genes always betray me and get me talking more than I want. But I'm going to spend them giving you an overview of an application or an analysis that we did on top of this data product. We spent a lot of time building the data product, and then what we did next was trying to use it to understand the British landscape of urban form and function. So a couple of overall summaries. I said it's 16 classes. 3 of them are arguably not urban. It's really hard to define any of those 3 in any way urban. But that's 3. That basically leaves 13 that are on areas that are either urban or peri-urban. There's 4 classes that are peripheral in our understanding, and there's 9 classes that define different types of urban fabric based on form and function. Now, how does this pan out over the landscape of Great Britain? What's the coverage of each of these classes? Well, the interesting thing here is that the 3 classes that are not urban take up 94% of the area of the land, But that's the 94% we don't care about, right? We care about the 6% that is arguably urban. And what you have in parentheses there is the percentage of units, of spatial units that take up those labels. So 94% of the area is non-urban, but that's only 50% of the polygons that we designed, that we derived. And this is just to highlight the point I made before, that what we really wanted was a spatial unit that brings to attention the urban, right? And by comparison, it sort of brings to the background, takes to the background what is not urban. So you can already see this right away here by the fact that 94% of London gets subsumed only into 50% of the spatial units that we're using. 5% of land and 40% of our polygons are in what we call peripheral, what the classes that we term as open sprawl, accessible suburbia, disconnected suburbia, and then warehouse and parklands. And then the 1% that's really the most interesting part is 10% of our units, and is what we call the most urban classes, anything from dense residential neighborhoods to hyper-concentrated urbanity, which is a small polygon around the neighborhood of Soho in London. Now, these classes, as I said, they almost fall into a hierarchy of its own, and or maybe that's what we find after looking at them long enough. But we did build a hierarchy of these classes that it's data-driven in the way that I'll explain in a second. What you see on this slide is a double entry table with the 16 classes on both rows and columns. So what you find on the off-diagonal elements is how much of one class is shared of how much of one class's boundaries are shared with another class. So for example, if you come down to the bottom, because it's the easiest one, 100% of the hyper-concentrated urbanity boundary is shared with the concentrated urbanity boundary. That's why you have this 100%. And that's effectively because this neighborhood, this Soho area that I was talking about before, is fully enclosed by, is like a donut of the other class that is concentrated urbanity. So all of the boundaries of the hyper-concentrated urbanity are enclosed by this, or are shared with this other class. That is not the case reciprocally, right? So only 29% of concentrated urbanity is with hyper-concentrated urbanity. So we use this rule, we use this property of shared boundaries to build this hierarchy that goes from wild countryside. And actually, there's a small typo on this figure that I should update. That goes from wild countryside, which is the Scottish Highlands up here in the north, to hyper-concentrated urbanity, which is in the city center of London. And we build this hierarchy by looking at, or by ranking the classes by how much boundaries are shared with every other class. But then we don't stop there. Now that we have a hierarchy of classes, we can use this hierarchy of classes to build a hierarchy of cities, to better understand how form and function structure the landscape and are arranged across different types of cities. And in some ways, it's a way of also classifying cities by the form and function role they play in the whole system. So what we do here is we start with a delineation of city. In this case, we're using the functional urban areas by the OECD. We look at what are the classes that you can find within the boundaries of a city, and there's an element of abstraction here that Martin created, where you represent the proportion of each classes in this concentric ring way, which Martin called created and loosely termed dish. And then I couldn't help being myself and proposing that since this is a visualization of spatial signatures, maybe this is a signature dish visualization. You can use these signature dishes to then apply it to different cities and rank cities by what is the most urban class that can be found within the signature dish. So at the very top is London, which actually has two classes that no one else in Great Britain has, concentrated and hyper-concentrated urbanity. But then one level below, you have a series of cities that feature metropolitan urbanity, which is another class, is the third most urban class, as the most urban class in the city. And this is where you would find Glasgow, where you would find Manchester, where you would find Edinburgh, where you would find possibly Bristol, if I remember correctly, but not a lot. It's about 10, 15 cities, no more. Then if you go down one class, then you have the cities that only manage to produce an area with regional urbanity. And that's where Newcastle, where Liverpool actually would be, sort of the second tier or third tier, mid cities. And then below you have local urbanity, there are towns, and then dense urban neighborhoods, there's effectively villages. And you can build that whole classification. You can automate it for all of the cities in Great Britain, and then rank them, and you basically arrive at a graphic like a figure like this, where you have on the horizontal side all the cities that we have, all the functional urban areas as defined by the OECD, and then on the vertical axis you have the 16 classes that we define, starting at hyper-concentrated urbanity and ending at wild countryside. And what we have in the color, the way we assign a color to each cell is by the proportion of area that the top urban class features in the city. So this is why on the second tier ones, where you get to metropolitan urbanity, they have lower and lower progressively proportions of that top, but they still have some. And then once you go down one, they have relatively high levels of that class. And as you move towards the right, they have less and less and less, though they still have some area in that class. And then you jump to the next level. And that gets this jagged shape of the graph that to us represents this idea of a hierarchy of cities, and that kind of structures the landscape. Okay, so that was 3 minutes. And the remaining 2 minutes that I have, I want to spend them giving you a preview or giving you an overview of where is our thinking on where to take this line of work forward, how to progress this work. And there's a lot of directions. This is only one in which we're already making some inroads. The gist of it is that we think the future of measuring form and function in this way passes through exploiting Earth observation and AI. And this is all the other hype terms that you saw before in the subtitle of the project coming at this point. And the idea was building this classification in the way that we've done it is the most detailed way we can do now. But it takes a lot of time, and many of the data sets actually don't get updated very regularly. In some cases, like in the census, they get updated every 10 years. There is a lot that happens in urban form and function in between those time spans that we would like to capture. And the way to do it, the way to go for us is through combining the classification that we've created with modern AI and computer vision and satellite imagery. So the point of it is that I don't know how much you're aware of this or you've been following this space, but the field of remote sensing and Earth observation has undergone nothing short of a revolution in the last 5 to 10 years. There's a lot more kit floating around the Earth than there was. A lot of that, or almost all of it, is much better than what we had just 10, 15 years ago. And that combination is translating the generation of a lot more data sets than before that are a lot better. And at the same time, we also have the parallel trend that we have a lot bigger computers that are also cheaper to use. So even if the data stayed constant, what we are able to do with the same data is much more, because we have better algorithms and bigger computers that we can pretty much all of us use. So when you take the three of them, we have more data that is better, and we have better ways of looking of using it or extracting meaning from it. What you have is that you can start doing things with Earth observation that just 5-10 years ago were pretty much sci-fi. And this is why I think Earth observation hasn't had as much adoption in urban studies as I think it will in the coming years. And it's because even though we've had satellites for a long time, what you were able to do with them it was much more limited than what you're able to do today. So there's a lot more data, and you can start seeing more data sets that are appearing. So ultimately what we're trying to do, and this is work in progress, so I can say some, but I don't have all the answers, is take maps like this one, like the one you've seen that I've talked about before with the signature classification, and then try to see how much of that we can extract from this kind of data from satellite imagery, from optical satellite imagery. So the link between the two effectively is through computer vision models that create probability maps for each class. In this case, this is the probability map for wild countryside. This is the one for urbanity or for urban centers. And then combining those probability maps into estimates that give us the class of each area. And you end up with maps that look like this, that are not entirely like this, but they are entirely made from a data source that is updated. You can get a mosaic that is cloud-free for the UK at least every year, perhaps every 6 months. So if we can get maps that look like this one every 6 months, it's a huge addition to what we can do only with a single cross-section of the signatures. And this is, as I say, work in progress. It's already been rejected in a couple of places, so it's been road tested, and we're improving it, and hopefully it will see the light of day soon. And with that, I'm 3 or 2 minutes out of time. Just to wrap up, this is to say that Urban-Forum function, hopefully I've convinced you it's important, it's interesting, and it's relevant, and we should and now can measure it in detailed, consistent, and scalable ways. And once that is available, which is effectively now, I think that hopefully I've shown you how the hierarchies is one example of the kinds of things that we can do with this type of new data products that we're able to create and develop now that we couldn't 5-10 years ago. And with that, I'll stop and shut up and hopefully take any questions. Thank you very much.
Yeah, thank you, Daniel, for your wonderful talk. It was very interesting and impressive to see what you're doing in your daily life. And maybe before we hand over to Martin to give his short input about the IOER related stuff, maybe you could pick up some of the questions in the chat and give us a little chance to have some answers on that. Maybe you start with the questions of Wolfhard Geile, who was the most active participant in the chat, and then maybe we will have the chance here of your.
Okay, yeah. So can this first question: when Foreman function encodes cities, geography, history, and even human activities, how do you connect Foreman function? And how would you see such a connection become specific, for instance, culture and climate, which are very different between regions? I'm going to try the 20-second version of an answer for these. Or a couple of thoughts. I don't think I have a fully formed answer entirely at this point, but how do you connect form and function? Ultimately is through space, and in a very practical way, it is, we measure the form of a location and then connect it to the function they follow by the location itself, but also more philosophically in the sense that form and function get encoded almost as a package. They're almost like a bundle, which is another term we've started using with Martin. How do you see such a connection become specific, for instance, to culture and climate? I think the answer to that is you need additional sources of data for specific applications. So if you're interested, so one example we did in the conceptual paper, it's a good, I think, illustration on how some of these things get encoded. We created for the conceptual paper signature classifications for 5 cities across the world with different data sets. And as a way to illustrate that you can do this in very different contexts. One of them was Medellin in Colombia, which is, if you know the cities it was originally developed at the bottom of a valley, of a pretty broad valley, and then over time it's been built over the mountains. Now, we did not include any information on topography or height or altitude or slopes, but then the classification itself reflected almost like a gradient the different levels of or the different stages, basically how far into the mountain an area was. And the reason is that we didn't include topography, but form and function encode that, because you can't build the same way at the bottom of a valley as you can on a slope that is 10% of inclination. So the kinds of buildings that you develop, the layout of the streets that you develop, the kinds of activities that you can undertake at at an inclination is very different from the kinds of things that you can do at the bottom of the valley. So all of that gets encoded and it's reflected in the classes. Now, I think if you really wanted to focus on some of these aspects, you would need to complement it with, I mean, that one was a very obvious one if you know the city. Some other encodings may not be as obvious, and then I think you need to bring in additional and auxiliary data. And then just a point about comparing between very different regions. This is something that we're very careful to say that it's comparable within a given classification. I'm not stating that if you develop two classifications separately with different data sets, you will be able to compare them directly. And some people see this as a disadvantage. The urbanist in me thinks that's a feature, is not a bug. It's basically a reflection of how interesting cities are, that you can't have a model to rule them all, or at least not at this stage. And I think that the point is, if we develop different classifications, comparing the classifications should help us understand what are the differences between those systems. And perhaps at some point you can build envelope classifications if you wish, but we're definitely not there. It's the same of why people get really excited about satellites and say, well, now that you have this classification, you can use the satellites to apply it in Africa, where there's no data like we do. And we're really, really, really wary of that approach, because it's a different animal, right? It's like taking a classification of birds and then using the method to try to understand lions. It's just a very different entity that you're looking at. What we think the satellites are really useful for is for rolling back and forward in time to see how a given system is evolving. And at some point, even that would also probably change, but it's at a much lower pace than across regions. Okay, so hopefully I said 2 minutes, it's been more like 5, but hopefully it gets at some of the points. There's another comment. I was wondering if the Germany LBMD classification for land use and land cover could be detail consistent and scalable in one. I don't know. I'm not familiar with that classification, but I would be really keen, actually, really interested in getting to know more about that classification, because for the data descriptor we made a comparison with other classifications that we thought were its closest relatives. We took the local climate zones, which is a very popular one in the literature. We took CORIN, which is a standard land use land cover for all of Europe. We took a couple other ones, but we didn't take that one, I suspect, because it probably wasn't available in Great Britain, so we couldn't directly compare. But I would be really keen on exploring what a comparison would look like. Okay, the one about what parameters we employ, hopefully I answered partially at least that by how we measure form and function. If you're interested, I can send over the papers that I mentioned in the talk, and there's a lot of detail there. But effectively, form, we use morphometrics, which is a nascent field that's changing, or that's advanced a lot in the last few years. And then for function, we use a host of different uses that the literature identifies. How do you see urban form and function influence or even change urban planning and design, and how do you see this happen? that's sort of the next 5 to 10 years of my job, hopefully. I wish I had a better answer. I mean, I think it's a lot of it is communication, is trying to embed it in discussions with people on the ground and showing them the value that inherently it should have. And we've had preliminary conversations in the UK with different government departments where sometimes at a very, very specific level, they need a way of parsing cities that allows them to, say, deploy heat pumps. And that's very linked to urban form. So if you have something ready that it's easy to work with and that they can access, it's one way in. But then there's a sort of longer conversation about how this gets embedded ideally into planning and design, but that's, not immediate. Okay, Robert, the delimiters lead to an area-wide non-overlapping segmentation. Have you considered allowing overlapping activity areas? We had such a requirement once when we tried to segment urban spaces according to their usage. We reached our limits here due to the partial multifocus. Yeah, this is a really good point. So in some way we do and we don't. The way we define the units, they're fully exhaustive, non-overlapping, because ultimately we want to draw boundaries. But actually, when we build the classification, as I said, every area also has information from the neighbor. So, and that's perfectly overlapping, right? So for every polygon, we're looking at least 10 topological steps away from that given polygon from which you're drawing information. You're weighting as less relevant the one that's 10 steps than the one that is 1, but you're still including it. But ultimately, and this is a simplification which we think is useful because we want to delineate. Now, you shouldn't look at those delineations as it's not a fence, right? There isn't a fence that says you're an urbanity now and then you're passing to sprawl. It's, if you understand cities, you know that that's not how it works. But ultimately, it is useful to delineate, to put lines at some point and say, this is our best estimate of where classes change from one to the other. In some cases, they're actually quite matching the reality when there is a big barrier, like a highway or a river. In other cases, it's a much less clear-cut definition, but we think it's still useful to be able to put a line. And so that's to say that, I think there's a lot to say about overlapping. I think they're probably a richer representation of reality, but they're trickier to then actually delineate classes. By which measure is the number of 16 classes preferable to 20 or 12? That's another good question. The reason is our best, was our honest pick, our honest educated pick. And the data descriptor, there's a lot of information on the clustering method that we did and how we picked 16. And if you've been involved in data-driven classifications like this one, as opposed to classifications where you have a canonical set of types, if you're trying to define the types in a data-driven way, there is no truth, right? You're basically parsing a complex multidimensional space, but there is no truth that says this is 15. What you have is some type of metrics and sometimes some scores. Some of them come from machine learning, some of them come from more nuanced or more qualitative approaches that suggest 16 might be slightly better than 17 or than 15. When you get to that detail, whether it's 14 or 16, it's much, it's harder to call. But what it's hopefully our data descriptor will convince you is that it isn't 45 or it isn't 4. There's a lot more granularity than 4, and probably we don't have enough to fill 45. But ultimately, with every data-driven classification, you have to pick a number. Okay, another question. Under embedding form and function, you mentioned the 150 indicators. How do you ensure that this data is spatially consistent, and how do you update it? So I'll start with the end. We don't update it in this context, but this is one of the, we do, but through the satellite imagery. And this is one of the limitations, because if you use a lot of data, then some of them may not get updated very quickly. How do you ensure that spatially consistent? There's actually a lot of work that I didn't have time to get into. I mean, this was 18 months of the brightest postdoc I've encountered in my time. So there's a lot of thinking that went into it that I couldn't mention today. But there's a lot of time that was spent on figuring out ways of transferring information from one geography to another one in a way that is sensible and scalable. So it depends on the data source. Some of them might come at census geographies, and we do spatial interpolation. Some of them are different features. So some of them, accessibility to amenities, for example, we calculate accessibility scores. So how many amenities can you reach within 15-minute walk on the street network? So for each type of variable, for each data source, we derive a way of transferring that into our canonical geography, the enclosed tessellation cells, to be able to have them all in a consistent way. Yes, then very happy to send the links to papers. And is 16 still small enough from a practical point of view of a policymaker? Maybe, I don't know. I mean, we have to start somewhere, and this was the first classification we did on these. I don't know if you know, if you look at other classifications, your demographic classifications, they are typically hierarchical. So they have a top level that is about 8 to 10, and then about 30, and then sometimes they have even a third level that is much more granular. We're sort of in between the really high level and the mid level. And both of those levels are useful in policy context in the UK, at least. So we're hoping that 16 strikes a balance. That's if you only have to build one, or if you only have resources to build one, which was our case, we try to be in between those two, really high level and super high detail. But ultimately, as I said, this is also subjective. Okay, I think that covers all of them.
Thank you very much for answering all those difficult questions. And I now would like to hand over to Martin Benisch, who will give information on our institute and how we somehow deal with these issues. And I would like to share our screen here, and this will hopefully be successful. Okay, so I think you now see our presentation slides, and Martin, please, the stage is yours.
So thank you, Daniel, again for your wonderful talk. It is a good tradition that also IOER will present something that is more or less related to your research. And today I have the honor to give an input statement from our research area, spatial information and modeling. And first of all, I want to inform you about our research area in a brief summary. Here you can see that we are stakeholder oriented. In the center of our research approaches is always the stakeholder. So we are interested in co-design and co-creation approaches. Our institute deals with spatial sustainability transformation, and our research area has 3 pillars. So you can see the 3 pillars of our research area. One deals with the database spatial information acquisition. So here I will lay the focus today with my input statement. Another important pillar for our research is dealing with indicators and spatial modeling. Here we are interested to understand land use and the competition of land. So recently we have a political issue to intensify our energy landscapes in Germany. And so we have a great pressure on our land. And here we have several projects that deal with land use challenges. And last but not least, we are dealing with spatial data infrastructure. I already informed you that we recently established a research data center at our Institute, and we have also a monitoring system that deals with settlement and open space development. Here we have a long tradition, more than 15 years. We are dealing with monitoring questions, and so all these technical aspects are combined in our new research data center. And now I want to come to our first pillar that deals with the data acquisition. And here I want to present some of our main research projects in the last years. You can see that we are interested to develop tools in close cooperation with stakeholders. One is interested to observe the open green space and to ask the users how to navigate in a city and what are the preferred areas and preferred features. And this app will help you to find the best place for your individual preferences. And you can also see that we are dealing with artificial intelligence. We are in a big consortia that deals with scalable data science. And here we are in close cooperation with Dresden and Leipzig, and the project is called SCATS-AI. Another important topic that I want to present today is the Coloring Cities initiative. And here we are, of course, in close cooperation with your institute, the Alan Turing Institute. And you can see that we are one case study, one academic test site. Germany is here also involved, and our institute is leading this academic test site. My colleague Robert Hecht is one of the persons who is responsible for the academic test site, and he's in close cooperation with Polly Hudson, and we are also happy to work with your institute. And in the future we are very much interested to be responsible for all academic test sites in Europe, and we have here a good starting point for further test sites in the future. And for our audience, you can see now Coloring Cities is interested. What is Coloring Cities? Coloring Cities initiative is interested to collect data on buildings. It is a big challenge in Germany to collect some more data on buildings. We do not have so many features in our official statistics, and for this reason, this initiative is very interesting for us to intensify the data collection, and it helps us to map information on buildings, to collect data like building age, building use, or the energy consumption, and several other features. So this initiative is very helpful for us to close the gap in data, and we form the basis for further research on building stocks. And this is a great chance not just to study Germany. It is a very good initiative to compare different cities. And why do we do this? So this data, it is collected from citizens. It is not just collected from agencies or other things. So our sensors. So the citizens are here the sensor, and they will help us to collect the data. And later on, when we will have some data, this forms a very good basis to combine it with our AI approaches. And here we use it as a first starting point. So we have some training data, and we are interested to fill our information when we will have a city with some information from citizens on buildings. So we are interested to predict data on the other buildings that are not filled with some features. So this forms a very good basis at the end to come to a complete picture of building features in cities. And we are here very much happy to cooperate with your institute, and we see a great potential for future cooperation. And when we come back to your presentation, it is also obvious that we have some similarities. So we are also dealing with land use questions, and recently I already informed all of you, we established the research data center, and here we have the interest to inform the scientists about data and to give some data to the scientists, but we are also interested to transfer knowledge to the planning authorities and to policy and to the society. And for this reason, we are not just interested with our research data center to make some tools or to make some data available. We are also interested to make some tools available, some simulations, and some spatial analysis. So our data center is not just interested in data as a product. Our research data center is interested in a bundle of products. And here we are in close cooperation with the stakeholders. We use co-design, co-creation approaches, and we want to make a good contribution to support spatial sustainability transformations in Germany. And coming back to your presentation, we are, of course, very much interested to understand land use change. I already informed that we are very much interested to understand the influential factors of land use, and we are also interested to study the different aspects of the competition for land. And so here, when we are dealing with Germany as a case study, we see also a great overlap for further cooperation to study land use changes and land use questions in Germany. And now I hope that we have a clear picture on our research, and we have also the possibility to continue with the questions to your presentation. But of course, we can also clarify some questions when looking to our presentation. So let's intensify our discussion.